Hello everyone and welcome to today's web broadcast. Our broadcast today will provide information regarding QLF benefits for dairy diets during the 2013 forage season. Our presenters today are Dave Lundquist, QLF Dairy Technical Services Manager, and myself, Lisa Davis, the QLF Dairy Product Manager. We'll cover several topics today, including information about the current forage situation, forage alternatives, the 2013 hay crop so far, the benefits of QLF for the 2013 dairy forage feeding scenario, and example diets using 2013 feeds. Our current dairy feeding scenario really starts as we look back into 2012. Last year, many areas experienced severe drought, resulting in a reduced hay harvest, lower corn silage yield, and in some areas, corn silage that had an altered nutrient composition due to the drought growing conditions. As we look at our current feeding scenario, some areas are still affected by last year's corn silage that contained less than optimal starch concentrations due to drought conditions, reducing the amount of starch that's going into the rumen to feed the microbes. Also, some areas have experienced depleted corn silage inventories or a corn silage inventory that won't last until this fall's harvest. Many areas experienced a lot of alfalfa winter kill, resulting in high hay prices. Many areas experienced a late spring and very wet conditions, resulting in some areas that could not be planted with their intended crops. Very late first crop hay harvest. The yield was good, but digestibility is lower than usual. Delayed corn planting, which may result in a silage that's less than normal maturity, especially if we get an early frost this year. And now flooding has washed away some newly planted crops or is going to slow emergence and reduce yields in some areas. But it's important not to despair as we consider each of these items, because this year we're going to learn new ways to feed dairy cattle and we're going to be successful at it. Flexibility and consistency will be key this year, and it will be very important to utilize nutritional and feeding management tools to maximize efficiency, minimize waste, and optimize utilization of 2013 feeds. Our first topic today is forage alternatives. And the chart on this slide shows the nutrient composition of corn silage and alfalfa haylage, our traditional forages, as well as 4 of our alternative forages, including rylage, forage sorghum, oatlage, and peas and oats. As we look at the dry matter for each of these, we can see that they're fairly similar across forage types. However, there can be a lot of variation in crude protein. NDF content of our alternative forages is usually higher than our traditional forages, as well as ADF concentration, and NDF digestibility is usually similar or slightly lower for the alternative forages as compared to our traditional forages. A few notes on forage alternatives this year. When planting forage alternatives, single species forage crop for lactating cows can help reduce variation. It's better to combine forages in the TMR rather than in the field for best results. Some of these forages were originally intended to be fed to heifers and dry cows, but now they're being fed to lactating cows due to low forage inventories. These forages do have an altered nutrient composition as compared to our traditional corn silage and haylage, and nutrient analyses, including digestibility, can be highly variable for these alternative forages depending on variety, planting, growing, and harvest conditions. Accurate nutrient analyses of these forages is imperative to optimize their use. Looking more specifically at some of the nutrients that have been analyzed for this year's small grain silages, this is information that was provided by Dairyland Labs. And as we look at the summary of their small grain silage analyses this year, we can see that the average crude protein concentration was 17%, NDF 54%, starch 3%, and NDFD was 59%. However, looking at the variability of each of those nutrients is very interesting, as crude protein ranged from 7 to 35%, NDF from 25 to 74%, starch from 0.1 to 20, and NDFD from 28 up to 90%. Looking more closely at the NDF concentration, we can see that about 75% of these forages that were analyzed had an NDF level of 50 to 65%. About 65% of the forages had a crude protein level of 12 to 18%. So that shows us that there is a good crude protein level in these forages, and there's plenty of fiber there. However, remember that fiber can be variable in NDFD, as the data shows 28 to 90%, and this is going to have an impact on the feeding value and ultimately on cow performance. So looking more specifically at what does 40 pounds of each of these forages provide nutritionally? Well, the dry matter of 40 pounds of each provide 14 to 18 pounds of dry matter per day. The crude protein goes from 1 to almost 4 pounds of protein. NDF goes from 7 up to 9.6 pounds, with our forage alternatives typically providing a greater amount of NDF. ADF goes from 4 up to about 6.4 pounds per day, with our forage alternatives usually providing a little bit more ADF as compared to our traditional forages, and digestible NDF going from 4 to 5.4 pounds per day. So when we look at these numbers, we can see that there is going to be different amounts of nutrients delivered by these alternative forages. We're going to look more specifically at a few nutrients here, starting with dry matter. We know that some of these small grain silages were put up very wet, and that's going to potentially impact the palatability of the forage and the TMR, the microbial stability of the forage and the TMR as well. Excessive moisture within the TMR can limit dry matter intake, and it may be necessary to reevaluate byproduct feeding as well. Consider the amount of moisture being added by these forages, but also the other wet byproducts in the TMR, such as wet gluten, wet distillers, etc. Now, the application and benefit of QLF here is that QLF is very dry compared to most TMR ingredients, even though it's a liquid. QLF dairy products are typically 62 to 65% dry matter, and also provide the opportunity to deliver microcurb and ultracurb to aid TMR stability through our TMR protector program. Looking more closely at crude protein concentrations, small grain and forage sorghum is usually higher in protein as compared to corn silage. So if these forages are replacing corn silage, typically less protein is going to need to be supplemented for the diet. However, if these silages are substituted for alfalfa haylage, additional protein supplementation is going to be needed in order to make up for the reduced protein level of the alternative forages compared to haylage. So the application and benefit of QLF here is that QLF products can deliver supplemental protein through urea. As always, it's important to monitor soluble protein levels, targeting 35 to 38% of crude protein. And remember that sugars from QLF products help enhance rumen ammonia utilization to aid microbial protein production, as they provide rapidly available energy to the rumen bugs as they're capturing that rumen ammonia. As we look more closely at NDF concentration in these small grain silages, they usually have a higher NDF level as compared to corn silage and haylage, and the digestibility of that NDF can be quite variable depending on growing and harvest conditions. Use of small grain silages creates a diet that's inherently high in NDF concentration, and many of these diets may also be naturally high in forage as well. With high feed prices today and high yields for first crop haylage and silages, some of these diets may actually be high forage due to economics. So as we consider this, it's important to remember that cows will eat about 1% of their body weight in NDF per day. So a 1,200 pound cow is going to eat about 13 pounds of NDF per day. When we look at our four forage alternatives, we can see that the sorghum provides a similar amount of NDF through 40 pounds as compared to corn silage and haylage. However, rilage, oatlage, and peas and oats do provide provide quite a bit more NDF through that 40 pounds of forage. Up to about 70% of the total NDF required by the cow can be coming from that 40 pounds of forage. So with all of that NDF going into the cow and wanting to optimize dry matter intakes, optimizing rumen efficiency is going to be very important. And molasses-based liquid feeds create an excellent opportunity to help enhance rumen efficiency. The application here is that the rapidly available sugars from molasses-based liquid feeds complement the slowly digestible fiber coming from those forages to help keep the rumen jazzed up and efficient. When we look at the rate of fermentation of different carbohydrate sources for the rumen, we can see that soluble sugars, which is shown on the far left side of the chart in the red line, is utilized very rapidly by the rumen bugs and can produce a lot of microbial protein, followed by starches, pectins, and fibers. So when we supplement that sugar within the diet from a molasses-based liquid feeds, we're stimulating microbial protein growth and helping to fill the gap in energy availability to the rumen bugs to help optimize rumen fermentation. Now, besides providing that rapidly available energy from the sucrose, which is the main sugar in cane molasses, we also know that as we provide that energy from the molasses-based liquid feed to the bugs, that energy is going to help to reduce rumen ammonia concentrations. As we provide rapid energy and reduce rumen ammonia, microbial protein increases. As microbial protein increases, NDF digestion improves as well. It's important to remember that while we have these benefits of rapidly available energy for the rumen bugs, that sugars and molasses-based liquid feeds don't negatively affect rumen pH when they're fed at the proper levels. So by stimulating microbial protein production and fiber digestion while not negatively affecting the rumen pH, molasses-based liquid feeds can help create the optimal environment for fermentation in the rumen to maximize fiber utilization. Our next topic is the 2013 hay crop so far. When we look at the first crop hay this year, there was a late harvest, but a lot of hay harvested. However, some of it has been rained on and most of it is high in fiber. The data on this chart is from Dairyland Laboratories, and it's the RFV values of the 2013 haylage samples that has been received so far as compared to the average RFV values for 2010 through 2012 fresh haylage samples. We can see that both time periods have a nice bell-shaped curve in their distribution of RFV values. However, the curve for this year's hay crop is shifted to the left and shown in the dark green as compared to the curve for the previous 3 years hay silages. So we can see that this year's hay crop is analyzing and showing a lower RFV, which means it's going to be less digestible to the cow. So when we have these lower digestible hay sources, it's important to remember that they provide less palatability, rumen available carbohydrate, protein, less rumen bugs are grown, less VFA produced, can lead to lower dry matter intake and less nutrients available for growth, milk, and component production. But also there can be sorting, ADF and NDF, and then mold and yeast concerns as well, and typically more weigh-backs and wastage too. Now, molasses-based liquid feeds can help improve rumen efficiency and help utilize these lower quality forages by providing rumen available carbohydrate and protein, stimulating microbial growth, enhancing VFA production, and ultimately forage digestion and dry matter intake. Also, looking more specifically at how do molasses-based liquid feeds stimulate microbial growth and VFA production on lower quality forages, this is some data from Diamond V Mills. It was an in vitro study where straw was incubated with a QLF product that was 22% protein and 27% sugar. As we look at this data, we can see that VFA production was stimulated fourfold, going from 22 up to 86 millimoles. So we know that the sugar and supplemental protein through that QLF product was stimulating microbial growth to improve VFA production, showing that the liquid was helping enhance utilization of that low-quality forage. Thinking ahead to 2013 corn silage, many areas experience late corn planting, and even with an on-time harvest, nutrients may be altered compared to normal corn silage due to the lateness of planting and the season's growing conditions. That immature corn silage may have higher protein, ADF, and NDF values and lower starch than normal. So as with 2013 forages, corn silage fiber content and digestibility is going to need to be monitored in order to maximize rumen efficiency. And again, accurate nutrient analyses will be imperative to the successful use of 2013 corn silage. So we've talked a lot today about fiber digestibility, but how much sugar is actually needed to enhance fiber digestibility? So let's take a quick look at the research to help answer that question. This was a snapshot from a research study that was a 60% forage diet that was 30% NDF, and researchers fed 1.3 to 4.2 pounds of added sucrose. When we look at the data from this study for dry matter intake, fat-corrected milk production, and NDFD, we can see that there were positive responses from adding 1.3 and 2.5 pounds of supplemental sugar from that sucrose, with dry matter intake going from 54 to 57 pounds per day, fat-corrected milk going from 90 to 96, and NDFD going from 50 to 57%. The positive responses in this study was obtained at the sugar level in the total diet of 5 to 7%. And it's important to remember that range of 5 to 7%, as other research studies have demonstrated optimal responses to sugar supplementation when the total diet sugar level is 5 to 7% of dry matter. In this study, the 7.5% sucrose treatment, or 4.2 pounds of added sucrose, which resulted in a diet sugar concentration of 10% of dry matter, did not have a positive response, as fat-corrected milk production was slightly lower, as well as NDFD. So the 4.2 pounds of sugar was too high of a level to obtain an optimal response in this study. We also should look at the fermentability of the diet. And to do that, I've shown the starch plus sugar values here on the graph. The control diet was about 31 starch plus sugar, and as that first unit of sugar was added, taking the diet sugar concentration to 5%, adding 1.3 pounds of sugar, the starch plus sugar increased slightly, but then it decreased as that second unit of sugar, going to 2.5 pounds of supplemental sugar, was added. Now, there was still a positive response at that 2.5 pounds of supplemental sugar, so the researchers were moderating the fermentability of the diet, reducing that starch plus sugar slightly in order to maximize rumen efficiency and get the positive response from the supplemental sugar. So the interpretation from this research study is that dry matter intake, fiber digestion, and fat-corrected milk production were enhanced with 1.3 and 2.5 pounds per day of supplemental sugar, and the diet sugar level was 5 to 7% of dry matter. The control starch plus sugar was a 31, which is within a typical target of 29 to 32%. The starch plus sugar increased slightly as the sugar went up to that 5% threshold to obtain the optimal responses at 1.3 pounds per day of supplemental sugar. And then the fermentability was decreased slightly as the starch with sugar was decreased with the second increment of sugar addition, as the sugar was increased to 7%. And there certainly is an upper level of supplemental sugar, as 4.2 pounds of supplemental sugar reduced milk production and NDFD. There was just too much supplemental sugar in this study, and the diet dry matter sugar concentration was 10%, which was above the optimal range. So the take-home message is that there's an upper limit to feeding sugar, and the most profitable diets will be 5 to 7% sugar concentration. A practical supplemental sugar level is from 1 to 2 pounds per head per day. The best dry matter intake and milk production responses to sugar levels higher than 1.5 pounds will occur in diets that have high forage levels, because that supplemental sugar is helping to enhance forage utilization. And when we move to levels of supplemental sugar more than 1.5 pounds per day, it's important to moderate diet fermentability. Bring the starch plus sugar down slightly in order to maintain optimal rumen fermentation and get the best utilization of that sugar. Now, besides stimulating microbial protein production and fiber digestibility, liquid supplements help to promote healthy TMR intakes to allow 2013 forages to get into the cow and get the best positive responses within the rumen. Liquid feeds help to enhance TMR palatability and consistency. They can aid dry matter intake consistency as well as dry matter intake and forage digestion, and help to reduce ration sorting and improve long particle consumption. Now, all of these items together lead to a desired uniform daily intake of rumen fermentable carbohydrate, degradable protein, and long particles, which helps to maintain the optimal rumen environment to keep microbial populations balanced, growing, and efficient, to maximize the nutrient supply to the cow, to best equip her to utilize 2013 feeds. And at this time, I'll turn the program over to Dave Lundquist for information in regards to diet examples using 2013 feeds.
Well, thank you, Lisa. It has been a challenging 2012 and 2013 in the dairy industry. But utilizing some of the concepts that Lisa has put forth, using QLF to enhance utilization of 2013 forages, I'd like to discuss 3 current customers in Iowa and how they're utilizing, in this case, rilage, small grain silage, to enhance their production and get their cows fed. So the first dairy has corn silage and rilage bales, let's call it baleage, on the farm, and that's all. And there will be no alfalfa purchased, as the cash flow is not there to make that happen, and it's not uncommon throughout the upper Midwest. So on this dairy, we're feeding 60 pounds of corn silage, 25 pounds of the rilage bales. A protein mix, ground shell corn, 5 pounds of dairy sugar 35, 5 pounds of linseed meal, basically because of its economic place to provide protein at this time, and 3 pounds of cottonseed. The dry matter in this diet is at 47.7. The forage dry matter is almost right at 50, 49.4% of dry matter. NDF is at 30.3. Crude proteins at 16.2, NFC's at 41.5, and starch and sugar is at 29.6. The as-fed intake on these cows is 118 pounds per head per day, dry matter of 56.3 pounds on this high group. The QLF product, dairy sugar 35, is 3% crude protein and 35% sugar. At 5 pounds, it's supplementing 1.75 pounds of supplemental sugar. Again, no alfalfa in this diet, and 40% of the NDF in this diet is provided by 25 pounds of rilage. Why is it working? Forage dry matter is lower than some, but the NDF is over 30. Cows are eating adequate effective fiber. Moderate starch level of 24% provides energy for the rumen bugs, but slow enough to minimize potential rumen upset. The 1.75 pounds of supplemental sugar from the dairy sugar R35 provides fermentable carbohydrate for the bugs and enhances fiber digestion, but does not negatively affect rumen pH. Sugar is in the 5 to 7% target range. 5 pounds of dairy sugar R35 provides palatability and consistency to the TMR. This next dairy, utilizing rilage, wet rilage, chopped, is low on corn silage, and so wet corn gluten feed and rilage are providing a replacement for the corn silage that's usually fed at twice this amount. Again, agronomy last year, drought conditions didn't bring the same amount of dry matter to the corn silage bunker, and we have to deal with that situation at this time. The grain mix is at 17.5 pounds, 6 pounds of a mid-bloom alfalfa purchased from a local hay auction, 5.5 pounds of a custom optimizer, 5 pounds of distillers, wheat straw, and megalac. The forage dry matter in this diet is under 50, 43.8, but the NDF is at 31.6, primarily brought in from the silage, but also wet corn gluten feed. Crude protein in this diet is at a 15.3. NFC is right at 40. Alpha carbohydrate at 26.4. The starch and sugar is at 27.8. Currently, this high group cow diet, they're eating 57.4 pounds per day at 108 pounds per head per day. The QLF information, the crude protein of this custom product optimizer is a 14% protein, 25% sugar. The supplemental sugar from 5.5 pounds of the custom optimizer is at 1.4. Specialty additives in this mix include Diamond VXPC and Zinpro 180. You'll notice this diet does not have one predominant ingredient. The 28 pounds per head per day as fed is the highest inclusion rate, and corn silage provides only 25% of NDF in this diet. But it's working. Forage dry matter is lower than some, but the NDF is over 30, so cows are eating adequate effective fiber and are holding a reasonably good protein and butterfat test considering the time of year. Moderate starch levels at 23% provide energy for rumen bugs, but slow enough to minimize potential rumen upset. The 1.4 pounds per head per day of sugar from the custom optimizer provides fermentable carbohydrate for the bugs and enhances fiber digestion, but does not negatively affect rumen pH. This ration contains 4 forages and 2 byproducts. Consistency is the key. 5.5 pounds of the custom optimizer provides consistency and delivers specialty additives. The final diet I'll talk about today is only slightly low on forage. You'll notice that this is a BMR corn silage fed herd, and we're currently at 50 pounds, and we're usually at 65 to 70, even 75 pounds based on dry matter. But we don't have enough to make it through. We want to keep it consistent, and so we've introduced silage to help to make that last. There's a good quality haylage, put up 7-1-13. That'd be first crop. TMR base at 8 pounds. Robot pellets, it is a robot herd, is at 8 pounds. That's the minimum for this system. There's 7 pounds of silage, corn, and a custom optimizer. The forage dry matter in this diet is at 60.6%. We do have reasonable quality forage. The NDF then is at 30, even at 60% forage. The NFC is at 39.2. Supplemental sugar, the sugar percentage of dry matter is 4.4%. This one mix TMR is at 113 pounds per head per day. The dry matter intake is at 56.1 pounds per head per day. The QLF product information, this product is a 7% crude protein, 22% sugar. The 4-pound optimizer is bringing 0.88 pounds of sugar. The specialty additives include Rumensin, Diamond VXPC, Selenosaurus AF2000, and Zinpro Avail4. You'll notice that there are a lot of forage in this diet. The consistency is the key. No ingredients are less than 4 pounds per head per day. And why it's working, well, the high forage dry matter, 60%, but the NDF is only 30%, indicating cows are receiving good quality forages. Moderate starch level provides energy for rumen bugs, but is low enough to minimize potential rumen upset. The 0.88 pounds per day of sugar from the custom optimizer provides fermentable carbohydrate for the bugs and enhances fiber digestion, but does not negatively affect rumen pH. This herd focuses on efficiency. Custom optimizer delivers and distributes the specialty additives which aid efficiency, rumen function, and reproduction. The take-home message from the field experience is that we can make anything work. Most profitable diets are 5 to 7% sugar. That's 1 to 2 pounds per day of supplemental sugar. And when moving to greater than 1.5 pounds per day of supplemental sugar, you need to monitor the starch and sugar, and you may begin to reduce the starch by 1 to 2 units to maintain your target of between 28 to 30% starch and sugar. Fill in with forage or digestible fiber. Maintain recommended NDF and PE-NDF levels. Monitor cow intake behavior and watch manure. Additional benefits of higher feeding rates include an increase in ration consistency. When you're feeding more than of one ingredient, it's very important for 2013 forages and feeds. There's quite a mix of materials going to in front of the cows. Increase in fiber digestion. Research shows that fiber digestion is increased when up to 2.5 pounds per day of sucrose or sugar from molasses is presented. Properly balanced carbohydrate is the key. Starch and sugar number, NDF, ADF, and NFC. The opportunity is always for more forage in the diet. Another take-home message with the additional benefits of higher feeding rates is an increase in ration palatability and a decrease in sorting activity. Higher feeding rates complement a precision feeding strategy. It provides a larger package to deliver and distribute micronutrients and additives. Even distribution of nutrients and additives in QLF products include within the product as it goes into the TMR, which controls shrink, and then when blended along the feed bunk and into the cow. Enhance your precision feeding strategy. Delivering additives through a liquid supplement reduces ration separation and feeding loss. Physical properties of an additive influence its distribution and consumption, the concentration, physical form, particle size, and density. On the right, you'll notice the graphic with different kinds of products that are often suspended into our liquid products. And in the center, you'll notice 3 small discs, and they are quarters. And that's to demonstrate just how much 1.5 grams per day of Selenosaurus AF or 300 milligrams per head per day of rumensin are. It's not a very large amount. And yet, they are dose dependent. So additive response is dose dependent. Delivering additives through QLF help ensure each cow receives the needed dose, as it's blended well within our product and is well distributed throughout the feed in front of the cow in the TMR. In summary, research and field experience show that liquid supplements may successfully be fed at rates to deliver 1 to 2 pounds per day of supplemental sugar. Properly balanced sugar, starch, and fiber is important, especially in 2013. Best responses to greater than 1.5 pounds per head per day of supplemental sugar in diets are with diets with a high NDF and or greater than 60% forage. Feeding liquid supplements at 4 to 7 pounds per head per day provides benefits for rumen efficiency and precision feeding. Thank you for your attention today and your time. If there are any questions, feel free to address any of those people that you see on the screen. Thank you very much.